Imagine a future where quantum advancements revolutionize how we tackle global crises. Picture encrypted messages that no hacker can breach, or life-saving drugs designed atom by atom through simulations. These possibilities are not mere science fiction, but tangible outcomes promised by quantum computing. However, as with any groundbreaking technology, the road to this utopia is fraught with challenges and risks. But here's where it gets controversial. While many assume quantum leadership lies solely in the hands of tech giants from the US, Europe, or Asia, Africa is quietly emerging as a formidable contender in this high-stakes race. To grasp the enormity of this shift, we must first confront a famous quote often attributed to Richard Feynman, the legendary physicist and Nobel laureate. "I think I can safely say that no one understands quantum mechanics." Yet, Professor Andrew Forbes of Wits University in South Africa seems to defy the sentiment. With his team, Forbes has cracked a fundamental problem plaguing quantum systems, positioning Africa as an unexpected yet undeniable leader in the field. Their breakthrough centers around stabilizing quantum entanglement, a phenomenon so mysterious that even Einstein once called it spooky. Entanglement refers to the peculiar connection between two particles that allows them to share identical physical states regardless of distance. This means altering the state of one particle instantly affects its counterpart, enabling instantaneous communication across vast distances. Sounds incredible, right? The catch? Entanglement is incredibly fragile. Any disturbance, whether it's light pollution, weather changes, or even something as mundane as a dusty window, can disrupt the delicate balance required for quantum information to flow seamlessly. This fragility has long been the Achilles heel of quantum computing. Until now, Forbes and his team have pioneered a solution that leverages topology, a mathematical concept, to create quantum states resistant to noise. By encoding information using specific topological properties, they've made it possible to preserve quantum data, even when environmental factors threaten to destabilize the system. Topology is proving to be a powerful ally in information encoding, explains Forbes. Our approach ensures resilience as long as some level of entanglement remains intact. What does this mean for the rest of us? Potentially, faster, more secure, and widely accessible quantum technologies. For instance, industries reliant on massive amounts of computational power could see dramatic improvements in efficiency. Quantum computers excel at solving optimization problems, tasks involving countless variables and potential outcomes. Think about pharmaceutical companies developing new medications, or financial institutions analyzing market trends. Traditional computers would require extensive time and resources to process such complexities, whereas quantum machines could handle them almost effortlessly. But let's zoom out for a moment. How did Africa come to play such a pivotal role in shaping the quantum landscape? Collaboration has been key. Wits University partners with Huzhou University in China, blending African ingenuity with Chinese manufacturing prowess. Together, they aim to challenge the dominance of Western powers in quantum research. Rather than guarding his discoveries jealously, Forbes champions open collaboration. "We can either work alone and stagnate or share our knowledge to accelerate progress," he asserts. This mindset underscores the importance of collective effort in advancing cutting-edge science. Now comes the million-dollar question. What happens next? As quantum computing inches closer to becoming mainstream, governments and businesses alike need to prepare for its transformative impact. Forbes serves as both a scientist and a policy advisor, helping South Africa navigate this uncharted territory. Through initiatives like the Quantum Roadmap, the government has committed funding for nationwide projects over the next 5 years. These efforts aren't just about fostering innovation, they're about addressing real-world challenges, from healthcare to cybersecurity. Speaking of cybersecurity, quantum technology presents a double-edged sword. On one hand, it offers unhackable encryption methods, ensuring privacy and security like never before. Dr. Isaac Nape, part of Forbes' team and a rising star in the field, highlights the potential dangers too. He points to China's recent advancements in surveillance equipment, capable of monitoring activity up to 30 kilometers away. While this raises ethical concerns, quantum communications also promise unprecedented levels of protection against digital threats. Using quantum states, information transmitted via these systems cannot be intercepted without detection. And this is the part most people miss: the ethical dimension of quantum computing. Who decides how this powerful tool is used? Should there be regulations governing its deployment? These are questions Forbes takes seriously. His team collaborates with legal experts to explore frameworks for regulating quantum technologies responsibly. It's a proactive step toward ensuring that humanity benefits from quantum advancements without compromising safety or fairness. The ripple effects of quantum innovation extend far beyond laboratories. Just as smartphones spawned entire ecosystems of apps and services, quantum technology will inspire new business models and opportunities. Not everyone needs to build quantum hardware to participate in the quantum economy. Entrepreneurs might develop software, tools, or platforms compatible with quantum systems, much like app developers capitalized on smartphone capabilities. In fact, governments are already investing in education and workforce training to equip individuals with the skills needed for this emerging sector. One shining example of academic-industry synergy is Wits University's partnership with IBM. As the first African institution in IBM's Q network, Wits gains access to a 50-qubit quantum computer and seed funding for research. This collaboration places South Africa at the forefront of quantum exploration on the continent, solidifying its reputation as a hub for scientific excellence. So, what do you think? Is quantum computing the dawn of a brighter future, or a Pandora's box waiting to unleash unintended consequences? Should businesses start preparing for a quantum-driven world, or is it too soon to worry? Share your thoughts in the comments below. After all, the conversation around quantum technology isn't just for scientists anymore. It belongs to all of us.